And in the previous video, we discussed limits from one side, one-sided limits. When we approached 0 for the function 1 by x from the positive direction, and we saw that we got to infinity. Right, and in this video, I'm going to be discussing with you the negative direction as we approach the same function from the negative direction. Okay, maybe I should erase this data stuff because we need new data, right? Yes, and this f needs to be erased as well, and yeah, it looks fine. It does. So now I'm going to approach 0, not beat at 0 because it is not defined. I'm going to approach 0 from the negative direction. Now I'm going to start simply with f of negative 2, and it gives me a negative 0.5, 1 upon minus 2, f of minus 1, minus 1, 1 upon minus 1, minus 1. Right now, f of 0 minus 0.1, which we get is 1 upon minus 1 into 10, which is minus 10. F of minus 0.01. If you increase the powers, you get to 100. Similarly, by increasing the powers, f of minus 0.001, we get to a minus 1000, right? So you can see values. So this would be plotted. Let me just now plot on the graph. Sorry, 1, this is 1, 2, 3, 4, 5, 6, 7. So 1, 2, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Yeah. And this side we have negative 1, negative 2, negative 3. Yeah. When we were on f of minus 2, we already approached negative 0.5, right? So similarly, as over here we approached 0.5, over here we approach negative 0.5. When we're at minus 1, we approach minus 1. When we're at minus 0.1, we approach all the way 10, which is not in the graph. Let's just assume if it is in the graph. I mean, we can extend the graph. There are no problems. Right? There you go. Okay, so negative 4, negative 5, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. That's the thing. So if we approach it from negative 0.1, which should be here, we get a negative 10. And then we approach, let's just see the data. Negative 10, negative 100, negative 1000. Same case. Same exact case. Just like this one. When we approach it from the positive, this case right here, the positive case is exactly the same. Just that the values are negative. So we get the same graph, but the values are negative. So our graph goes on and becomes something like this. Again, not my best attempt to draw the graph, but still the graph would look like this. And this approaches infinity, yes, but in the negative direction. So for our means, we use minus infinity. You might have seen here that I've written infinity and not plus infinity, because as a convention, if I write 1 and not plus 1, in place of plus 1 I write 1, they both mean the same thing. Similarly, in case of plus infinity, if I write infinity, it just means the same thing. Infinity, this is plus infinity, right? And we have minus infinity. So we saw that the limit as x approaches 0, again the same convention. This is the positive sign, this is the negative sign. right, of f of x. So this limit of f of x as x approaches 0 from the negative. Now what do we get here? We get minus infinity. What? We got minus infinity, guys. You saw? From the positive direction we got infinity, and from the negative direction we got minus infinity. And these are just not equal, right? So you saw the limit of f of x as x approaches 0 from the positive, and the limit of f of x as x approaches 0 from the negative are not equal. And this means that if the limit from positive direction and the limit from the negative direction are not equal, then the limit, in this case as x approaches 0, sorry, not plus, I'm supposed to write approaches, as x approaches 0. And now I'm not going to use any convention. I've already used the convention from the plus over here, convention of the minus over here, and I've seen that they are not equal. So I just simply and the question in the previous video which was asked was, I have to find the limit as x approaches 0 of f of x. So x approaches 0. So we saw the limit from the positive and the negative. And when the limits are not equal, we say that limit as x approaches whatever number, in this case 0, of f of x does not exist, because the limit is approaching two different things. It does not exist. So this is how we find limits from graphs. And in other videos we would be teaching you how to interpret graphs, infer limits from graphs, you could say that way. Thanks for watching.